All right, let's finish up batteries. Okay, a secondary battery, as we touched on a little bit before, is the other classification of battery. So primary battery, one-time use, but secondary battery is a type of electrical battery which can be charged, discharged, recharged many times, and its composition is different. So you'll see here that the physical makeup, that way that the chemicals are configured into a little packet is different than a primary battery. Secondary batteries rely on electrical energy. We talked about the type of terminology, but the way we choose secondary batteries is the allowable depth discharge, its cycle life, energy density, discharge rate, and temperature limits. And they're commonly paired with a power generation source. These are the Artemis 18650 cells. You'll see that they look a lot like the AA battery size. They are lithium-ion cells. These cells are just like those from larger spacecraft. So you'll see here that the individual cells are the same size, but you can, for a larger spacecraft, you stack them in bricks. And then there's a covering, so it makes it look like it's a much larger battery, but in reality, it just consists of more of these same individual cells. To achieve the necessary power storage requirements for the whole mission lifetime, we need to pay attention to these different metrics. So you want to size the depth of discharge for how much energy you need to provide to a system for a persistent amount of time. For cycle lifetime, you need to think about how many times you need to discharge and have that energy provided to your system. How many times are you going to do like science operations, which is the most energy intensive? Given how many times you need to do your science operations, that determines your cycle life for the batteries. If you have like 1,000 required operations, then you have to cycle your batteries at least 1,000 times. Your energy density is going to relate to the amount of energy you can provide per mass unit. Your discharge rate is going to correlate with the different loads on your spacecraft, how much power they need to operate. So it's more dictated by the components that you want to power, and then you choose the batteries that can supply that charge rate, that discharge rate. And then temperature limits. Batteries are sensitive to temperature, which we'll talk about in a little bit. But you want to make sure you choose batteries that can survive all of the thermal environments that it'll experience in its mission lifetime. Okay, so battery care. Last lecture, when we were going over requirements, you could see that the external documents, all of our reference documents, were very particular about batteries. There were a lot of rules about batteries. So we'll go into the nuances of why we have to be very particular about our batteries. We have to care for them. So batteries are sensitive to temperature. They're sensitive to temperature not only in storage, so a battery will discharge on the shelf even if it's not being used. Here is a graph of a lithium-ion battery where it's self-discharging, and it differs at different temperatures. So you'll see that at the lowest temperature, the battery discharges at the lowest rate, whereas at a high temperature, you can see that over 12 weeks, you get like 35% discharged. So the way to avoid the self-discharge is to put a battery in a very cold place, like a refrigerator or a freezer. Temperature also affects the rate of discharge. So if you're operating a battery at a very hot temperature, you'll see that the discharge curve, where voltage and hours, you'll see that the curves look different. At some really cold temperature, if you're operating a battery at a really cold temperature, the discharge curve will look like so, where you're not getting as much voltage out. And the reason for that is because the chemicals within the battery, such as these aqueous electrolytes, will start to freeze and seize up at this really cold operating temperature. So this is the reason why when you're in space, you want to be very careful about the thermal environment that you're subjecting your batteries to. Maybe you want to put heaters or coolers around your battery to avoid your battery seizing up and, stop the battery. You want to prevent the battery from not giving energy. You kind of want to baby your batteries. Okay, now we'll talk about how to care for batteries when it comes to discharge. Batteries are subject to fatigue. So remember we were talking about structural components, and there's some like minimum stress and maximum stress that you're cycling in between. There's an analogy that you can make for batteries. There's some minimum depth of discharge and some maximum depth of discharge, and that's offering the fatigue. Okay, so let's look at if you're varying your depth of discharge, so between 0 to 100%, then you can expect that your average life cycle is going to go down over, like if you discharge more. If you don't discharge very much, so you're just like oscillating between like 90% to 100%, then you can get quite a bit of life out of your battery. But that does restrict the amount that you can discharge, the like usable amount of energy you can have per operating mode. So in reality, we'll see that you have to make a trade-off between the amount of discharge, the depth of discharge, so the amount of energy you can provide to your satellite for some duration of time, versus the amount of cycles that your battery will survive, which limits your mission lifetime. So yep, just want to keep that in mind. The deeper you discharge, the less life you'll have. And then let's look at the discharge rate. So depth of discharge is, depth of discharge is some unit, whereas the discharge rate is the derivative of that fundamental unit. Yeah, this is energy. This pertains to energy, and this pertains to power. So let's say that you have components on the spacecraft that require some spike in energy. So it requires a very high discharge rate. If you have a high discharge rate, say like at 18C, you'll see that your discharge rate affects the amount of, let's see, it's going to affect the state of charge of your battery and affect the effective capacity of the cell. So discharging at very quick rates damages the battery cell because, there are chemicals within the battery that don't like to be perturbed so much. You can do permanent damage to the internal configuration of the battery. Okay, here is a little bit about why that happens. Okay, if you fully discharge a battery, it can cause irreversible damage to the plates. The plates being the, I'll just show you in a picture. Yeah, you can do irreparable damage to the plates within a battery. Okay. While normal sulfation is reversible, excessively draining a battery or leaving it in a state of discharge will allow the soft lead sulfate to crystallize. At that point, charging the battery will still cause some of the sulfation to reverse, but any crystallized lead sulfate will remain on the plates. This sulfate cannot, under normal circumstances, return to a solution in the electrolyte, which permanently reduces the available output of the battery. The other detrimental effect of allowing crystallized lead sulfate to form is that it effectively shortens the lifespan of the battery in an empirically measurable way. If too much of this crystallization is allowed to occur, the battery will no longer be able to provide enough amperage to start, and it will have to be replaced. Oh gosh, so we're almost out of time. Really quickly, so that was about battery care. When it comes to battery operation, you need to know how much capacity your battery has left. The way to do that is to measure the voltage of the battery, and you can correspond that voltage with a % of capacity. The problem with that is that you'll see here there's not much variation in voltage. It's pretty flat over here for this band of 20 to like 80% charge of a battery. So this is state-of-the-art kind of research where, given these very sensitive measurements of voltage, can you figure out a better knowledge of how much capacity is left in your battery? You definitely don't want to be in a position where you think that there's more battery left than there really is, so that you overly, excessively drain your battery and then permanently damage it. So yeah, this is an ongoing problem in electrical engineering. And then these are the specs to our battery, which I'll have to get to another time, but I kind of wanted to walk through it and just like talk about how that affects the way you design a spacecraft. Okay, I have 1 minute left. There's also the last form of rechargeable energy is mechanical kinetic energy in the form of a flywheel. Pretty much you have a rotor which has mass and it's spinning really quickly on this bearing. You can slow down the rotor and get energy out of your system. That's how you would power your system. And when you have excess energy or you have power generated, you can put it into this system by spinning the rotor faster. And the reason why this is not really used too much is because it's very high in mass. It's not very efficient. Okay.